All right, friends, time for the hands-on part. We're going to pick a resin, pick a starting pH, and run our first linear gradients. This is the spot where a lot of new scientists freeze. They think they need to meditate their way into the perfect starting conditions. But no, this is scouting. We're just building the map. Step 1. Pick the resin. Remove variables, don't add them. Your first resin doesn't need to be inspired, it needs to be familiar. If your group loves Toso's salt-tolerant CEX resin, use it. If everyone's comfortable with Capto Q, use that. If all you have is a relic of CM Sephiro's from 2017, maybe don't start there. But here's the good news. Vendors love giving out 1 milliliter samples. Ask, and chromatography goodies will appear like magic. Early development is not the time to reinvent resin selection. That's a phase 2 problem, when you have data, time, and a stronger emotional constitution. Step 2. Pick the starting pH, reconnaissance mode. Your pH doesn't need to be perfect, it just needs to make chemical sense. Check. Protein pI, resin charge, recommended pH range, any "my protein hates this" stability warnings. A simple rule of thumb. Start about 1 pH unit away from the pI. pI 8.5 doing CEX? Try pH 7 to 7.5. pI 5 doing AEX? Try pH 6 to 6.5. And if you're confused, here's the cheat code. Lower pH, protein gets more positive. Higher pH, protein gets more negative. And please respect known protein drama. If your molecule freaks out below pH 5, don't go below pH 5. Step 3. The linear gradients. Now the hero experiment, the broad linear gradient. Yes, someone in the back is already whispering, "We don't use gradients in GMP." Relax, Kevin. This is development. We're just mapping the terrain. Start with a 0 to 1 molar sodium chloride gradient over 20 column volumes, CV. Collect about 1 column volume fractions. Find where your protein elutes. If purity is high, you'll see it right on the chromatogram. If purity is low, break out SDS page, CE-SDS, LC-MS, or, bless your soul, Western blots. Then run narrower gradients to zoom in. If the first gradient says 175 to 400 millimoles, great. Now tighten. 0 to 100 millimoles in 1 CV. 100 to 450 millimoles over 18 CV. 450 millimoles to 1 mole in 1 CV. Maybe now your protein elutes 190 to 245 millimoles. That's your step recipe. Load and wash near 150 millimoles per litre. Elute around 250 millimoles per litre. And congratulations! The hard part is basically done. Once you've picked your wash and elution points, it's always worth running a quick confirmation step gradient run, just to make sure the real-world behaviour matches what the linear gradients predicted. It takes almost no time, and it gives you the satisfying right to say, "Yes, Kevin, the step gradient works. Thank you for your concern."